right? To find out the relative maximum error on a surface area. So we are talking about dA is equal to uh, 4 pi 2r dr, right? That's according to the differential formula. So that's basically 8 pi r dr.
And you already know R and you know dr.
So this is the maximum error evaluating that r is equal to 42 over pi and dr at 0.5 over 2 pi, which is 1 over 4 pi that you're talking about. So this is your maximum error. So you're going to be substituting 8 pi. R will be 42 over pi times with the R will be 1 over 4 pi. So which give us 84 over pi. And this is area, so it will be in centimeters square. The rate of change. Is that the answer?
That's part of it. So
No, I mean like this is the first question answer, right?
yeah.
Okay. So that is basically the maximum error that they talk about, this dr. Okay. And what is a relative error? So if you take biologies or like any lab, if you do the experiments, you know that relative error is basically talking about what? Absolute error divided by what? The actual value. Okay. So what is absolute error? That is basically talking about the measure, right? The value that you get from the experiments, which is the measure, minus the actual over the actual value. So that's basically the relative error formula. And if you want the percentage, you just multiply by what? The 100%. Are we all found so far? Yeah. So now, what we need to understand, right, this formula from what we see in the different subject to interpret it into mathematics is this. The measure and then the actuals are basically, you are talking about what? The change in this case will be the change in area. Are we all following so far? Because we are measuring the area, and then with the actual area that we know from the formula, divided by what? The actual area. So in mathematics terms, this is what we are seeing for the relative error for this particular problem. Are you all okay with this?
Yes.
And from differential, we learned that this change in A is basically approximately what? dA. So when we talk about relative error, we are basically talking about change in area over the actual area, which is approximately, we can approximate with using the differential, which is dA over what? The area. So we already found out dA already, right? Which is what? 84 over pi, and divided by the actual area is 4 times pi times my r squared, which is 42 over pi squared. And if you simplify that, that will give you the relative error.
Equal down, it was divided by 4 pi r squared?
Yeah, because the actual area of the actual surface area for the sphere is this right here.
Oh, I see.
Right? Mm-hmm. We have a formula already. Does it make sense?
Yes.
So therefore, like that's the reason why I mentioned before. This differential is useful because, like, a lot of like estimations in a different field will be able to use it. So think about in biology. You can talk about right here is a growth functions, and you can talk about relative error in the growth functions, approximating with the differentials and stuff. Chemistry will be the reactions, change in reactions.
For these types of problems, in the wording, I like the problem before this when I started solving it a different way using the delta of volume, and I figured out that equation first, and then I plugged it in, and then I realized
the delta, which delta?
Like here, let me see if I could just pull this here. Can you see me?
Yeah.
Can you see my? Oh, you probably can't see it, can you?
No, I can't.
You can?
It's dark. I cannot.
Okay. So what I mean is that volume equals x cubed.
Maybe I do it this day. Show that again.
Oh, sorry. There you go.
Okay, now I can see it.
So you see how I started solving it with that first, and then I realized, oh, that's not what it's asking me. So then I started using the differential to solve it. So I guess what I'm asking is...
How can you put like plus or minus 0.1 on x?
Because I didn't realize that I was looking for the maximum. I thought it wanted me to find the minimum and the maximum. So I started doing it like that. Anyway, so I was like, okay, so I realized that's not what it wanted. And then I started changing it to use the differential rather than this. But I guess what I'm trying to figure out is in what words will the question ask me to solve it as I did in the first 4 lines versus using differentials to find the relative error and percentage error? Is this something I have to care about?
The first line is like when you talk about delta V is that's basically the change in Y value already.
Yeah, but they gave me very close answers both ways. Like if you see, I ended up with 270.901.
It is true because remember what's differential is basically talking about is trying to approximate for delta V in this case.
Yeah.
The differentials of V is basically trying to approximate for the delta V.
Okay, so that's why I'm using the differential to estimate that.
Yeah, that's the reason why you're getting like a very close answer right there.
Okay.
Because you are basically like now thinking about the actual function change in function value comparing with the differential, which should be very close because we are basically basically approximating this change in. See, you can say that change in A is what change in delta. So you don't. What the point is? What happened is you don't do all of those computations on the first few lines. You can basically with the differential idea to get the computations made and then. Does that make sense?
And then what? It got cut out.
Oh, you can basically use a differential to approximate and close approximations, and then you can evaluate it fast also.
Okay, that way I could just double check my work or something.
Pretty much because what you're looking, what I look at it when you look at the first few lines is, the basically the change in the volume, which is you're looking at the actual number, right?
Yeah.
You're looking at the actual number. So right now, see, the question is already telling you use the differential to estimate the possible maximum error.
Yeah, I didn't read it all the way.
So already telling you to use the differential. Right? What you are looking for is the actual maximum error already. Right?
Yeah. 2.9 wasn't as bad as 2.8. 2.8 was rough.
Yeah, it's before the test, you can say that on the day of the test, everything should be fine. You like everything, okay?
Well,
otherwise you will not like me either.
I didn't know how to find the volume of a trapezoid trough. Do you?
Google it.
You can't Google it on the test day. Can you?
I mean, like the formula, you need to know it, right?
Do you know?
It's not easy to Google a calculus, Professor.
No, I mean...
she's talking about the formula. Like I said, that is basically like, something that we're not used to doing it.
Yeah.
Right? And, some instructor will be expecting you remember all of them, some instructor is a little bit loose on that. They might provide it to you if they ask like that kind of tough, formula to remember. Yeah. So like I said, like, everything's like the fundamental one is a fair game.
It took me a really long time to do 2.8. Each problem took me like half an hour.
That's good. So that means that you look at it in detail and then think about it, right?
Yeah.
And then that half an hour, if you go back and do some of the problem again, it should be way faster than your first time doing it. So it's normal if you take time on the first time doing those problems.
So I want to share my screen and show. Oh, sorry, somebody else is sharing.
Oh yeah.
Yeah.
I don't know. It's me sharing.
Yeah. Could you stop?
My board.
Okay, cool. I'm going to share my screen and I'm going to pull up that problem real quick so I could ask a second question. Hold on a second. And then, so, desktop. Okay. No, I don't think this is it. Hold on. Where is that other one? Is it this one?
See, that program is not allowed on the test, okay?
No, this one. So they did it a different way. So that one I sent you, that problem that I sent you through the email that you notated, which is right. Is it here? No, you don't use Canvas inbox, do you?
No, I sent it back to you through the email. Yeah,
so what I ended up doing is, and I looked here and they're solving it a totally different way by substituting y second prime into the whole thing. And I haven't seen this one before where they used that. And I went the long way and then I went in a reverse direction to get the second derivative. And here they just started substituting it. I'll just slow down. So here's step one.
Isn't it you need to pay for that website?
No, it's $15 a month.
Oh my goodness. Can I get your account?
Yes, you can get my account.
No, I was just kidding.
No, it's fine.
Because I tried it before, like, and I thought I remembered that CHEGG,
Oh, it's all right. I'll give you my account.
Okay.
So that part, I understood that, right? And then when you get down to y equals x plus 3y squared, right?
Okay.
And then they start using this, subscript, and I'm like, okay, I haven't seen that before. But you see in step 5 where it says simplify the above equation, like I just haven't seen that method.
Yeah.
Is this advised?
There's another way to do it, but we never talk about it in here.
So this isn't going to be on the test where I'm going to get this problem?
Let me see what they are actually trying to do. go back up a little bit.
Mm-hmm.
Up. Down. So basically, go up a little bit up, a little bit up. Not all, not all, not all, not all,
Right here?
not all. I want to see together with, go down a little bit. Okay, stop. So what they do is, I don't know where they putting the solve the above equations y prime. So, and after that, I don't know what solving for this part right here. What? Do you see that? So y, see, denote y by y sub 0
Yeah.
at x equal to 0.
Yeah.
Seeing why they solving that part. So the question never tells you what is 0. That's a particular point already. The question that you asked me is to generalize on the second derivative, which is, you see that equation number 1.
You
right?
cut out.
Do you see the equation number 1 on that page?
Equation number 1 on that page.
Yeah. Do you see that all the way on the top, the equation when you put inside the parentheses 1?
Yeah, x plus 3y squared.
Now, see, notice that when they take the second derivative, they just basically take the derivative on that equations right there.
Okay.
So it is okay to do it because they are using implicit differentiation idea to take the derivative instead of solving for prime first and then take the derivative again.
Okay.
So that can be done.
Okay.
That could be done. I don't understand where they get it from, because the question's never telling you to evaluate at that point anyway.
Yeah, that one really confused me about why they would use that.
So basically, that point is that, x equal to 0, that part, I don't think is necessary. I don't know why they show it to you, right?
Okay.
But what maybe is like, you taking on, on the step 5 of 6, you can still use equation number 1 to take implicit differentiations for the second derivatives. That's perfectly fine.
Okay.
Right? That's perfectly fine. As long as you can keep track of your notations, then it will come up to be the same answer at the end anyway.
Okay.
And
all of that just to get to 0, which is so freaking crazy. I guess they're using the subscript to get to 0 and simplifying it all the way.
Oh, they are basically showing to you how to evaluate at a particular point.
Okay.
See, I don't know why they put in x up, evaluating the first derivative as 0 and the second derivative as 0.
Yeah.
Right?
Okay.
Maybe what they are trying to show you is like in some other problem when you need to do the evaluations, right? Then you can try to approach it that way. But hey, if you already find a second derivative, you can just plug it in and then you got that already anyway.
Okay.
Because when you're evaluating the second derivatives, right? Not this one. So when you are evaluating the second derivatives, on the second derivatives, if you're using implicit differentiations, what's going to happen is on some of the part, it will be xy prime plus 2yy prime plus 2xyy prime, something like that, for example, right? Mm-hmm. After you take the second derivative. And if the question asks you to evaluate the second derivative, right? Instead of you substituting back y prime with x and y, okay? You can basically evaluate the y prime at a particular x value that you want, particular x and y value that you want, and then you substitute that value right away for here. That's what they probably showed to you.
Okay, I see.
You see what I'm saying?
Yeah.
Because technically, you're gonna have to substitute y prime with x and y, right? Mm-hmm. Whatever the formula that we get from y prime, so that I can evaluate this, y double prime at what x, y only. But now, if you don't want to substitute back y prime with x and y, then I need to evaluate the y double prime at x, y, and y prime at particular x, that particular x and y that we are talking about, this value.
Right. Okay.
So that's basically what they are trying to show to you, from my understanding.
Okay.
So why they particularly choosing 0 to give you that example? Maybe it's easy to evaluate it for you to see it, I guess.
Is it going to be that complex on the test?
What letter grade you want for the class?
Man, I don't know. I mean, this feels like a rough chapter for some reason. Mainly because it just took such a long time to get through it. But yeah, anyone else have questions before I ask another question?
If anyone has a question, if not, I'm gonna take off.
No, I have more questions. Going once, going twice. So I guess another question is, could you give me in simple words the difference between a derivative and a differential? From like 2.7 or 8, I forget the difference.
Basically, when we talk about derivatives, we are looking at the notation dy dx as one symbol.
Leibniz notation, right?
Yeah.
Yeah.
So what happened is they're writing into that notations for some reason, which is basically, to interpret it a different way later on, which the differential is basically talking about. Now we can look at the notations, right, into the ratio of dy and dx, which is dy and dx now can be represent at a value. Which interpretation is basically the same as before, which is the slope of the tangent line. Mm-hmm. The change in y and the change in x of the slope of the tangent line.
Also, they're both the same thing, just in different terms.
Because before, we only know the dy over dx as one symbol, right? Mm-hmm. Such that it represents the slope of the tangent line. Now that the differential basically tell us hey, we can look at this dy over dx as a ratio, which now the way that I can interpret it is what dy is basically the change in y of the slope of the tangent line, and then dx as what? The change in x on the slope of the tangent line.
Yeah.
Right?
Yeah. So
you need to go back and then take a look at not only your textbook, because I know that the Stewart textbook is literally sucks on this part. They don't go in very very into detail of it, if I remember it correctly when I'm looking at it. Right?
Yeah, it doesn't.
Try to Google it or type it in something. Well, if you want to go to the next level, I can show it to you this. Let me do this.
Yeah, because I noticed that when you do the Leibniz dy over dx equals f of x, or sorry, f prime of x, right? Whatever. But then when you get into differentials, now it's dy equals f of x times dx, meaning that you divided dy by dx and the other side by dx too, right? Or you multiplied both sides by dx, that is.
It's basically you are putting the definitions of two first, and then by knowing that differential value, dy over dx is y and dx are two separate values, and then when you divide it by dx on both sides, that ratio, which also representing the slope of the tangent line, is right there.
Right. It still equals the same thing.
If you go in I go like this,
Some interesting recommendations on your YouTube, dude.
The reason why I don't want to show it to you is because, like, you know, in a different, the one that I'm looking at is because they're using like different old notations, because this is an old professor, calculus. Maybe he explained better than me. It's like when I look at it, I think like, you know, it's a lot better than me, but I have some backgrounds already, so I totally follow what he's saying, but some of us might get confused. That's why I don't want to, you know, point out on those, you know. Even like, you know, if you look at his lecture on delta epsilon proof, like go through how, you know, is the idea is developed to go backwards to get the actual proof, you know, because we find out the epsilon first, right?
Yeah.
We find out using the epsilon part, you know, to find out the delta. So he sort of developed on those things, like, which I think is very neat. But you know, I understood it, but it's a little bit, I don't know. Wait a second. What did I want to?
Well, I tried looking one up myself, and it was a video of some guy writing on a piece of paper, and he covered the paper with his hand the whole time. So I was like, that's not helpful.
Look at it from MIT, you know, MIT stuff.
Okay.
This guy, is it this guy?
Oh, that's real old.
Yeah. I like this guy better.
Okay.
When I'm looking at.
Can you type the link into the chat?
Yes, but you know there are a lot of part 2 complex variable lecture 2, functions of complex variable. No, this is not. This is maybe this is a complex analysis. Oh, this is in differential equations, but what I want is not differential equations. I want like calculus 1. Let me do that. Calculus single variable. Calculus MIT. Yeah. And from there, probably, you know, there are a lot of like different person that talk about it, and this is the guy that I like to watch. I don't know, you know.
I'll take a look at
it. I did not watch all of them because I look for only what I want. So you can see that the whole set of this, you know, you need to basically like, you know, look at what you actually need.
Okay.
This. So you have to like go through from each lecture point to another lecture point to see which topic is in there, and then from there you go for it. Let me see. This is a URL that I just get all the whole series of it. And you should look at other instructor on that MIT also. You know, everybody they explain it differently from that point of view. You see that this guy is still in like black and white.
Yeah.
So that's how old it is. You know, sometimes the old school ways of explaining is much. I think I like it better. I don't know.
The following content is provided under a Creative Commons license. Your support will help.
Started playing automatically. Okay, sorry about that. Anyway, all right, cool. I mean, and also, can you just give us like a study guide for this test, since we all made the effort to stay an hour extra? You're good at that.
Huh? What? You
study guide? Study guide for this chapter test? Come on, like you tell me sometimes, like, hey, study this.
Oh yeah, like follow the reviews.
The reviews, literally.
That's a lot.
Your reviews are. This review was not as good. This chapter 2 test review, I don't think you've looked at it in like 2 years, but it's It's not that good.
What's wrong with it? You know, give me a complaint and I will look into it. What is not good? Which part is not good?
The part that is...
it's a lot. There's mix of limits and the rate and the...
So are you telling me that you don't want to do a lot?
No, it's not that it's a lot. That wasn't what...
No. I'm asking her questions.
Oh.
No, I'm just saying, at least if you know where to focus exactly. Like sometimes you find yourself focusing the wrong thing, and then when the test come, you're like, oh my God, you know.
Let me tell you this. If you wanna continue on this education path and get the degree of master or like bachelor degrees, when the instructor say that the test is on chapter 1 and 2, you should focus everything in chapter 1 and 2.
Okay. All right.
Okay. So that way, whenever the instructor asks you from those chapter, then you'll be ready for it. So you don't have to pick and choose anymore.
Yeah, I see.
Okay.
All right.
Let me just ask you real quick about this right here. Okay.
Welcome to Calculus Visitor.
All right.
The most difficult lecture.
Who's that? Is that me or you?
Why is that? Who's opening that video?
Somebody else opened it on our chat here. Okay, so right here, for these problems, is this the language? Well, I mean, for I guess the word problems, are these basically going to be the way it's worded on the test?
The word problems? You talk about number 41 and stuff like
yeah,
that?
just like from 40 through 50 or 40 through 49. So like this is pretty much the words that we could expect on the test, right?
You know where I got those problems from? Maybe if you Google it to like every university, from math departments, those are from their tests. I just basically copy and paste it.
Okay.
All right. And like I mentioned before, this review is created when I was taught the first time on calculus. When I taught the first time on every class, I spent tons and tons of time. And these problems, basically, I go into USC, UCLA, University of Texas, somewhere else on their math departments. Whoever posts they're tested from those universities, I take it out with whatever is appropriate to our class and then put it in there. Because you guys are not only taking my class, you are taking this class, plan to go into any university. So I have to make it ready for you guys. I don't know. And I even cut it off some of the portion that, I think
too much.
Yeah, too much for us.
Well, we have a lot going on. I mean, that's the only reason. It's been a lot. I might lose my house.
If you want, like I said, if you want to go to, if you want to look at into how other university instructor asks, let me share you with the screens. Usually, this is how I go and I look at it. I can just type it in. UCLA math departments.
They use the same book.
Yeah, a lot of university use this Stewart book, but there's a difference between some of them is using early transcendental, and then some of we are not using early transcendental because we will not see the logarithms and exponentials until our second class of calculus.
Yeah.
Okay? But anyway, they posted somewhere. I don't know what happens. Like the website looks like they updated it.
Because you haven't been there in a while.
It doesn't look like when I was back then, like 10 years ago.
Yeah, really? No way.
Yeah, they changed it. Anyway, I can say that UCLA old test, something, type it in like that, it might come up. Tutor, UCLA Math Department, Math 3A. I don't know what that math is, but let's take a look at on Math 3A. General cost descriptions, I don't know. I just found it like that.
Okay. Oh, there's the exponential growth and stuff you're talking about. But then there's the rates of change.
The limits, see that?
Yeah.
The limits. But that is basically, this is not it. This is basically talking about the course outline, what they are covering on their first course of calculus. This is basically calculus for life science students, not the calculus course for engineering or something, like that. You see what I'm saying? So it's different. So, you can basically look into it in the departments, and then or even go into an instructor block, and then they can be some instructor post their old tests.
When are you going to be available tomorrow afternoon for office hour?
Tomorrow? No, tomorrow I'm not available afternoon at all. Like I said, I'm starting from 3 o'clock, and I will not finish until 10 o'clock with all the office hours straight up. Because one of the classes is 3 hours.
Okay.
And
what about
another
Thursday?
Class is 2 hours. I'm free in the morning, but it will be depend on when I wake up.
I can get up at any time you like.
I should see the old UCLA old test. I don't know. Before I found it like this. Math 31A. So I don't know. I found it this way before, and then it went in pretty neat. And USC might be easier to define it.
Okay.
I got some problem from USC also. So if you want it, you can do that.
Okay.
Extra prompts.
And then when can I do office hour on Thursday morning?
I have a class from 12 to 3:15 at Santa Monica.
Mm-hmm.
Okay. And after that, 3:15, then I'm basically free.
So from 3:15 to 4:30? But then you don't have a break. Can I just catch you in the morning at 10 or 11?
If I wake up.
Well, I just want to make sure if I have questions during my review tomorrow that you're going to be able to answer any last minute questions I have.
Okay, you can send me an email tomorrow if you have questions.
And then you'll check it Thursday morning?
Yeah, and then we will talk about on Thursday.
Okay, cool.
I'm not sure Thursday morning though. In between, is it between my class end and then the next your class?
That's
okay?
45 minutes before the test though. Can you just do it before you go? Check your email before you go to Santa Monica though. It's test day.
I will try.
Thank you. Thank you.
Bye everyone.
Thank you. Bye.
Bye.